In this presentation we are going to look at control charts, and this is without that curve to the middle, this would look like a control chart. Essentially the main components that we're looking at are as follows. What we have here in the middle is this mean line, okay, so that's X bar there, okay. Up at the top we have the upper control limit, okay, UCL, okay, and that is 3 standard deviations above the mean. And likewise down at the bottom we have the lower control limit, and that's 3 standard deviations below, okay. So those are the 3 key sort of lines that we would have on our control charts. Now we actually would have the 1 standard deviation and 2 standard deviations as well. Those lines, they're not as particularly important. They are useful for pointing out some of the rules that you would use. That's related to the Nelson rules. But anyway, so what is important here is that if you remember the normal distribution, okay, the normal probability distribution is, and essentially the key things about that is that between mean minus 3 standard deviations, which will be here, to plus 3 standard deviations, what we should have there is 97.73% of all observations. So such that outside, which is outside those lines, should only be account for 0.27, as in about 1 in 400 or 1 in 350 or something like that. Okay. Likewise, within 2 standard deviations, approximately 95%, and within 1 standard deviation, that should account for 68% of the observations. Okay. So that's why those lines are there, okay, and that's quite important to remember for the other sort of how to interpret these charts, what they call the Nelson rules. Okay, so let's sort of get into our presentation here. So what we're going to do is calculate the control limits. Okay. Now this is the type of layout of a question. So what we have here is a batch of 4 observations, okay. So what we have here is 140.5, 139.9, 140.0, and 140.5, okay. And the mean of those 4 observations is 140.22. Also, though, what's quite important here is the range, and something that we might also be interested in. It's not actually sort of featured in this data set, but we might also be interested in the standard deviation as well. Okay, that might appear as another column. Okay. Now, an important remark here is that the batch size here is equal to 4. Okay, that's going to be quite important on it later on. Now, you might sort of see that there's 100 items. There's 100 of these batches. Okay. That's not really particularly important, that 100 value, okay, but the batch size of 4 is actually quite important. Okay, now so essentially what we do is we calculate the mean of the first batch, the mean of the second batch, the mean of the third batch, and so on, all the way down to the full 100 batches, and we get the overall, the grand mean of the all of those means, and that turns out to be X 140. We would denote that X double bar, which is the mean of the means. Okay. Similarly, what we might do for the ranges is we would calculate all the range values, 0.6, 0.5, 1.1, and get the mean of all those range values, and we would call that R bar. Okay, and in this case it's 121. You might also find the average of the standard deviations, and we'll call that S bar. Okay, that's quite important as well. Okay, so in this data set, what we're going to do is have R double bar as 140 R bar is equal to 121. Okay. And separately, what I'm going to sort of say is that it's not actually given in this data set, but I'm going just to sort of set the mean of the standard deviations as 0.20. Okay. Now, so what we're going to do is calculate these control limits. Okay. So the first one we would have here is we're going to calculate the control limits of the process mean. This is the X bar chart. Okay. Now, collecting up our data, X double bar, that was 140, plus or minus 3, okay, over S bar, that's the mean of the standard deviations. Now, here I'm just picking a value of 0.2. N is important. N is the batch size. So, in this example that we're using up here, the batch size was equal to 4. So, N is equal to 4. Okay, and the square root of n is 2. Okay, square root of n equals square root of 4. That's equal to 2. Okay, now this value here, C4, that's important. Where is that coming from? Okay, so what we have to here is this is what is called a correction factor. Okay. And you use these in calculating those control limits. I'll just go back to the control limit calculations here and we'll just sort of spot all of the correction factors. We have C4 there, C4 again for the process standard deviation. We have C5 there, and also we'd have D3, capital D3 and capital D4. There's actually quite a few of them knocking around. Now, what is the important thing here is the batch size. Okay, so in our example, the batch size we were using was 4. So we're going to use this row here. Okay, so C4 there is 0.9213. So let's use that. That is not. Let's use the right pen color here. 0.9213 times 2 over 0.2 divided by that times 3. Okay, so that's actually just a little bit of calculator work. Let's actually just sort of I'll tell you what, I'm going to calculate it in a minute. S bar plus, let's just look at the process standard deviation. S bar, what we're going to sort of say here is S bar is 0.2, okay, plus or minus 3 times C5 over C4 S bar. So that's not, C4 again is 0.213, S bar is 0.2, and C5 is 0.3889. Okay. Finally, and again, just sort of, that's a little bit of calculator work. R bar D3, R bar D4. R bar is 1.21. Okay. Now, so D3 is 0 and D4 is 2.282. So what we have here is 0 times, well, okay, let's go at this like this. 1.21 times 0 and 1.21 times 2.282. So that's how we calculate the control limits there. That's necessarily going to work out as 0 and 1.21 times 2.82. So what I'm going to do is actually just sort of pause at the machine for a second and just calculate all of those out, and I'm just going to comment a little bit more on this. There's an important comment left to come. So that is, working that out, I make that to be 140 plus or minus 1. I'll just go to 3 decimal places, 1.3025, 4 decimal places, and that works out to be 138.6975 to 141.3025. Okay. You can sort of correct me if I'm wrong from the I might have made a slight error there somewhere, but I think overall I'm pretty much correct. So essentially what we would draw here, let's just say for argument's sake this is our process control, our mean. So our mean line here would be 140. Our lower control limit would be 138.6975, and our upper control limit up here would be 141.3025. Okay, and essentially what we're expecting is that 99.7% of the values should be within those boundaries, the upper and lower control limit. Now, what I'm going to do now is the second one. The second one is actually quite interesting, and it is the standard deviation, process standard deviation. I'm just going to scroll back down here. There it was. 0.2 plus or minus 3 times that there. So let's just calculate that out. Let's go to a blank page. So there we have it again. So it's 0.2 plus or minus 0.2532. Okay, working that out. Now just be sort of pay attention to this. Is important to pay attention. That would be minus 0. Wait a second. It would be minus 0.0532 to plus 0.4532. Now that indicates here that you could have a negative standard deviation. Okay, now that's not allowed. Okay, so what you would do here is replace it with 0. Okay, so what you would do here is the answer would be 0 and 0.4532. Okay, you cannot have negative standard deviations. Okay, so replace a negative value for a standard deviation with 0. So on our control chart it would look something like this. 0.2 here. Down here would be 0 at the lower control limit, and up here it would be 0.4532. Okay. Now, and necessarily you wouldn't see anything down here. Okay, it would be baselined at 0. Okay. Oops, there you go. The last one is the range chart. It's actually a very straightforward calculation. It would be 1.21 by 1.21 by 0.2282. That would be 0.2761. Let's just go back to where we see what I'm talking about. This one here, that would work out to be 0 and range. Oops, my pen is gone all over the shop. Range, control limits, 0 and 2761. Okay. So anyway, that ends our control limit presentation.